All right, let's start the next section. And this is actually a section I really enjoy because we're actually now going to do some application problems with calculus. And these can actually be kind of fun and extremely useful in business and science and things like that. So we'll look at several different types of examples. Here's going to be the idea. We're going to have some objective function. An objective function is a function that has an infinite number of potential values. So like, for example, we might have the function f of x equals x times y. And that's going to have a different, and so notice this would actually have two inputs. So it would be f of x comma y, but that's okay. The point here is that we have two inputs, x and y, and that's leading us to some third output. The idea here is that this has an infinite number of potential outcomes, a different one for every x and y. All right, that's what the objective function is like. The constraint is something that holds x and y together. Like, for example, we might say that x plus y has to equal 30. All right, and so that's going to be a constraint. The idea is you want to maximize or minimize, depending on what the case may be, your objective function. However, you also want to make sure that the constraint is also true. And it turns out that what this means is that frequently we will get only one answer. And so what I mean by that is there will only be one thing where this will be minimized or maximized. So for example, just looking at this, if x was 0 and y was 30, that would work because you'd get 0 here. But then don't forget, x and y could also go negative. And so maybe there you can go even lower than 0. So you see what I mean? It's not super straightforward how to maximize or minimize this just based on guessing. And so that's where the calculus comes in. So the idea is we got an objective function, which is some function, just call it f, equaling something that we care about, and a constraint. And here's what we're going to do. We're going to plug the constraint into the objective function, then take the first derivative, set it equal to 0, and that's going to tell us our answer. So let's just look at an example. Of all the numbers who sum to 40, find the two that have the maximum product. So this is exactly what I'm talking about. Our function is going to be, our objective function is going to be just x times y. And our constraint is x plus y equals 40. So find the two numbers that multiply together to make the biggest number possible and that add up to 40. So we could try 1 and 39, 2 and 38, 3 and 37, or maybe a negative and a positive, except that wouldn't work because it'd be negative. Or it might be a decimal and a fraction. There's an infinite number of things we have to check. So instead, here's what we do. First, solve your constraint for one of your variables. So do you agree with me that your constraint you could write like this, y equals 40 minus x, just subtract the x over to the other side? So solve your constraint for one of your variables and then plug that into the objective function. So f is equal to x times, and I'm going to substitute 40 minus x in for y. Just like that. So because y is equal to 40 minus x, I just plugged it in for y, and there we go. Go ahead and simplify. So that's 40x minus x squared. All right. Here's why that's beautiful. Now we've got our objective function, but we've got it in terms of only one variable. And so that means that we're going to be able to take the derivative and set it equal to 0. So in this case, f prime is going to equal 40 minus 2x, just like that. Set it equal to 0. 2x equals 40, and we get x is equal to 20. So that is one candidate for our absolute max and min. Now, when you're doing these kinds of problems, you'll remember from the previous section that we also need to test the endpoints, and so it's always a good idea to do that. In this case, we don't really have endpoints because we know that a negative won't work because it'll be negative, and we know 0 won't work because we're trying to maximize the product. And so there's not really endpoints in this one, so that means our answer is going to be 20. So that's x. How do we find y? Well, x was 20. You just plug it into your constraint equation. Y equals 40 minus x. So just plug in the answer we found. Y equals 40 minus 20. So y equals 20. So there you go. Notice that 20 plus 20 adds up to 40. And if you do 20 times 20, the maximum value is 400. And that's it. If you make x or y deviate at all from 20 and 20, you're going to get a number that's smaller than 400 when you multiply them together. So if, for example, if y was 10 and x was 30, that'd be 10 times 30 is 300. You can see that that's less than 400. That's pretty much all there is to this. You'll notice that we had some symmetry here with them being the same number. That can be quite common to have that kind of symmetry. Not always, but quite frequently we can get symmetry like that. In the next video, we'll look at another example of a maximum, minimum. These are called optimization problems. We'll look at another example in the next video.